Yeah, we could. I still have a lot of connections there, and so if there's interest, oh yeah.
Let's talk about it.
Yeah, we could talk about that, and that's what, like, really what I'm doing with Steve's company. I'm helping them with this business development and negotiation when they have someone to negotiate with, to help them in the negotiation. So.
Okay. Moving on to our next exciting talk, we have Gary Durack. Gary has been actually with the university working on flow cytometry technology, and he actually was a true entrepreneur, took that technology into a startup company that's called iSight, and a few years later this company was successfully acquired by Sony. And if you go by the research park by the iHotel tonight, probably you'll see a Sony sign there. That's the company that Gary started and served as CTO up to the acquisition point. So thank you so much for coming.
Yeah.
We're eager to hear some of his personal experience about this very successful story on our campus. So thank you, Gary.
Thank you very much, and it's a pleasure to have a chance to talk with you all today. It was interesting listening to Jed's talk and the interaction here. It exposes the fundamental, which you're all learning, of how difficult it is to communicate concepts. It's very difficult, but it's true in all business and in really all life, but in business especially. You have the point of view of the technology experts and gurus, and they have their sphere of understanding, and then you have the people who actually use the technology and have to pay to fund it and bring it forward and develop it. And it's very difficult to communicate concepts back and forth. And so one of the ideas, which was led there by what NSF is doing, is say, reduce it down to one sentence and then just argue about the one sentence, which is the quick value proposition, and that's one way. But it's also just a matter of relationship. And what you'll find out, and I'm sure you're finding out in your careers already, is that progress, human progress, is made through relationship and people still communicating one to another. And I don't care how big the business deal is, if it's a $100 billion acquisition or a $5,000 acquisition of a pizza parlor in town, ultimately that business deal was done by two people who had different ideas of what they wanted to do, coming together, sharing their concepts, developing a relationship, communicating, and deciding to do something. And so big things, really big things, are done by a very small group of people getting together to decide to do something. And so I encourage that, and I love all the skills that they were talking about. So, and I love sketch. And I got to get started on my talk, but for just earlier in my talk, my very first invention was the 1979 engine fan for the Oldsmobile station wagon. And so that's strange. I was working as a mechanical engineering technician for Brookside Corporation in McCordsville, Indiana. And we had the contract to build the engine fan for the 1979 Oldsmobile. And we came up with this staggered blade design that made the engine fan, at that time, it wasn't like the little plastic ones, big steel engine fan, made it about 10 times quieter. And most of the noise from the engine came from the engine fan when you ran it up fast. And so I learned at that time, and I tried to explain, I wanted to talk about the acoustics and all the really cool things we thought in the design, but all my value proposition was the engine's quieter. And so I learned that a long time ago, was that's all anybody outside of the engineers wanted to hear, was it just makes the engine quiet. And then all the GM executives thought, yeah, that's great. So, okay. So let's see, which page down? Which thing do I hit to make it go forward here? I'm hitting space bar and I'm hitting page down, it doesn't move. Excuse me? Oh, there's a clicker here. I thought you said that didn't work.
Arrow.
Ah, okay, arrow. Okay, there we go. Oh, up here. I was trying to keyboard. This keyboard? Okay, there we go. Got it. Thank you. Now that I've had my training on the technology, this is what I was going to talk about briefly here today. A little bit about my experience, flow cytometry. I'm glad we have cell sorting front and center today. I've spent 35 years trying to make cell measurement and cell sorting devices, and so I'd love to hear about new innovation and stem cell sorting. That's pretty exciting. I'm going to talk a little bit about startup companies at different stages and so forth, and hints on finding opportunities. My talk is very much about exposing you to the idea of career path and potentially what we refer to as startup companies. And so that's what I really want to hit on a little bit today. But because I've got biophotonics people, I get to talk about what I do in fluorescence measurement just a little bit. I just put some photos up here of my, I guess what I'll say is my startup journey. This is what was the incubator at the University of Illinois back in 1999 when I started out doing things. And I had a little 800 square foot lab in there where I started the company that became EyeSight, and we did consulting engineering work for flow cytometry and cell analysis devices. So we started out as really a one-person show and grew to about 15 people in there. By 2008, we had a 23,000 square foot manufacturing and engineering facility where we designed, manufactured, sold everything, a bunch of high-speed cell sorting machines, and this was part of our manufacturing floor here. And then in 2009, we were purchased by Sony, and the company was renamed Sony Biotechnology, Inc. in 2012, and still has a presence here in the research park. Prior to this, I'd been in the university system running core fluorescence cell measurement laboratories and so forth. And prior to that, I'd worked at Coulter Corporation, where the blood cell counter had been invented. And so I've kind of been working in how to measure cells all of my career. And this 10 or 12 year period was kind of in a very exciting time of building a business that started in my extra spare bedroom and ended up being able to sell it on Madison Avenue in New York, which was a lot of fun. So flow cytometry, you guys, again, this group probably knows a lot about flow cytometry. The idea is you have a suspension of cells, and you can flow the suspension of cells in single file using some hydrodynamic focusing here. This would be a Crossland-Taylor sheath flow system. You focus a laser beam down such that the beam waist is about the same size as one cell. So you have a stream of single cells that flow through the laser beam and they scatter light. You label them with monoclonal antibodies or dyes and so forth to measure characteristics. And you can take pretty pictures of that like that with it was about a 532 nanometer laser. So a cell sorter is really cool. It uses technology very similar to the original inkjet printer technology. So you have all the, as I said, the flowing cells and the laser beam and so forth moving through here. And you use a piezoelectric transducer to couple acoustic energy to the stream and break the stream up into nano-sized droplets, usually a little bit less than 1/10 of a nanoliter in volume, so that droplets will tend to contain no more than one cell. And then you measure the cell, you wait for the cell to break away, and you place a charge on the surface of the nanodroplet right before it breaks away, and electrostatically steer it in an electric field into whatever you want to capture them in. And so this is just a schematic of how flow cytometries work, and it's really cool. And I built machines that could run about 100,000 cells a second through and do this operation. And it was just fun to watch. It's really fun to make something and see it actually work. This is a picture of what my machines looked like when I did that. So big fluidics up here and deflection plates here, collection tubes down here. This is a strobe image of the little nanodroplets being formed that were used to sort. So then the droplets were just individually sorted into the wells. And of course we have to keep the cells alive. The only reason you sort cells is to grow them up and do something with them. And we could sort populations that were less than 1 in a million in their concentration. So that's flow cytometry. Do you have any flow cytometrists here? People that use flow cytometry, cell sorting? You know something about it, right? Yeah, no, you do spectroscopy. I'm going to show you a spectral instrument in a minute. And actually on this machine we had a spectrometer, and we looked at autofluorescence and actually looked at using autofluorescence to identify stem cells on the machines there. So these were the machines that I made, and these were the pictures. My company was the first to introduce the idea of putting these machines in parallel inside of a biosafety cabinet. Again, this was very attractive to the stem cell sorting crowd. So we made big cell sorters like this. We made little machines like this that were used as analyzers. And we made juice down here. And those of you that might be in any type of a diagnostics environment where you're going to build a test or diagnostic, it's the juice that always makes the money. It's the disposable. It's the reagent. You put the gadget in. It's the razor blade theory concept, really, that goes through there. And so this was kind of what we had built there at iSight. And Sony came along and said, we're interested in you. And so now you see what Sony machines look like. A little bit different. This is my generation. Of course, I had, these were things we were just bending metal and put them together because that's what I could afford to do. But Sony's engineering team and industrial design team went together, and so they made these machines. And the machine on the left here is a cell sorter, and it does everything that one of my channel machines would do and sits on a benchtop. This is actually a spectral analyzer, so this provides a complete spectrum on a cell-by-cell basis. And so it has a dispersion device built in and a 32-channel PMT in order to directly measure the spectrum in a little bit under a half of a microsecond per cell. But these are the two machines that they're manufactured in Tokyo and being sold now by the flow cytometry company. So it was a lot of fun going from the original, just starting with nothing and doing the design of these instruments, getting them working, getting involved with the customers, getting out in the field. One of the most fun things for me, though, and one of the most exciting things for me, was the ability to work with the team that was assembled around me at my company. And I think that if I look at entrepreneurship, or what I found most gratifying about starting and a company, it was the relationships, it was the team members working for me, it was watching people have good jobs and be able to send their kids to college, and it was really just living together. It was a great environment and something I enjoyed a great deal. And I think my greatest satisfaction was being able to help people have jobs. I just liked that. I still like doing that. A couple of innovations, and why did Sony care about getting the flow cytometry business? It's because of these things, these little chips here. What you may not know, and this kind of goes back to value proposition. So why was Sony interested in this? Sony has these big plants to make DVDs. And DVDs are micro-injection molded. Each one is injection molded, and I didn't know that before I got involved. And Sony has the most advanced technology for high throughput micro-injection molding of anyone in the world. And they have these huge plants set up around the world to stamp out DVDs. One of the largest plants in the world is in Terre Haute, Indiana, not too far from here. And that's where most of the DVDs in North America come from. Another huge one is in Salzburg. Well, Sony had identified years ago that DVDs were no longer going to be the way that music content and video content would be distributed. They could see the handwriting on the wall with streaming. So they said, what could we do with this micro and nano injection molding technology that we have? They have a huge investment in these facilities. What could we make on a consumer scale? And their strategy has settled on making microfluidic devices in mass for medical and diagnostic purposes. And so one of the reasons they chose flow cytometry, it had fluidics, it had optics, lasers, all the things you have in consumer electronics parts that they have, photo detection and so forth. And it had a challenging problem in microfluidics to be able to make devices to do this. And they thought that flow cytometry would be the way to teach their engineers how to make these things, these kinds of things, which they've now successfully done. And so if you go back to my picture back here, and you see all this crap up here, or technology that we developed, which is now crap up here. All of this thing right now, well, all of that fluidics gets reduced down to this, a disposable little chip. So now, every time that you want to, if you're going to run a patient, or you're going to run another sample, and you want to make sure you have zero molecular carryover, you snap in another little microfluidic chip, which automatically loads and sets up, and you're off and running. So they did an enormous job of taking the kind of the macrofluidics, reducing it to microfluidics, and making it disposable. And this is the same type of chip, but it has a little quartz port put in it because this is the one they use with their spectrometer. And this is a picture from their website. of the multiple prism system that provides the dispersion element and then focuses into the 32-channel PMT to give you the fluorescence per each cell. So that's it for technology. I gave you a little technology because I had you here and I just wanted you to know about flow cytometry. Everyone in the world should know more about flow cytometry. Okay, but let's talk a little bit about technology and companies, if we could. And this is always a problem, is which comes first, the invention, the technology, intellectual property, or the product idea, which is kind of like the need, and you guys have been talking about that. So I want to talk a little bit about a famous person that from the state of Illinois here that was involved in that. Is anybody here familiar with blood cell counters and the Coulter counter, impedance-based cell counting? You ever heard of that, seen that? You're all Biophotonics people, but this was impedance. Well, this is the guy that invented this. This is Wallace Coulter. I had the benefit and the privilege of working for Wallace in the 1970s and 80s. He's passed away now. Wallace lived in Chicago, Illinois, and he invented the impedance blood cell counting system, which is salt water with a small aperture, about 100 microns, and 2 electrodes, one inside, one outside, and you pull the cell through here. It displaces some of the salt water and changes the impedance of the hole, and you can count the cells and size the cells. And so Wallace became a multi-billionaire off this invention, basically. And so rarely does a technology do this. The Coulter counter was first introduced in the late 1950s. There was really a zero market for automated hematology, which is cell counting. Today there's a little over a $6 billion market just in the US. So this is a $6 billion market that was created by an invention over the period of his lifetime, and it's still largely used for that technology. Prior to that, they just counted them on microscope slides. And so I just point this out that in 1960 there was a $24 billion US healthcare market. Today there's about a $2.5 trillion healthcare market, and the creation of this new a market of $6.1 billion, which I'd say in that case the technology and the need kind of hit. The need that, boy, blood cell counting is really important in clinical setting, and I've got a technology that can make it a lot cheaper to go. Now, if you ask me, how did Wallace make a lot of money off this? I mentioned the juice before. He made these machines which are reasonably expensive. He made most of his money selling salt water, which ran on the machines. And because you had to use up a certain amount of isotonic fluid each time you ran a cell sample, and 80% of his billions was made by selling salt water to hospitals all around the world. That's the difference between the technology and the business proposition. So it required high technology to do the measurement. People didn't buy the technology, they bought the solution, and the profit mechanism was the salt water. So, about how many startups are there? This is just a number I pulled down off the internet lately, but I'd say this is interesting. There's about 100 million new startup companies every year, and there's 472 million entrepreneurs worldwide, so I feel less unique today as a result of that. And so if we think about, now, what's the purpose of a technology startup company? Why do we have a technology startup company? Technology startup company bridges between the academic setting, maybe where something's invented or there's an idea, and I'd call the commercial setting where you now have public funding and things are really rolling for profit with a big company like GE Healthcare or something like that. And so in between there is the startup company. And so what the startup company does is it takes some intellectual property and adds maybe some grant funding from the government, adds some private capital from investors and resources, expertise and time from the principals, the inventors, which is usually donated in one way or another, a lot of contracted expertise, and then has some really smart people down here during the development period that I call the hardworking staff. And so they combine all that together over a short period of time, hopefully to produce a product that fills an unmet need. But as Jed talked about before, too often the product ends up in failure and doesn't meet the need because it wasn't designed. But the point that I really want to make, that I want to make here, is the real purpose of the startup is to increase the value of the intellectual property. It's starting with a value here because maybe it's untested, unproven. People don't know about it. And what you want to do in the startup is you want to increase the value of that intellectual property and spend less money increasing that value. So maybe you put in $1 million, but now the technology is worth 10 million. And so now you've made a significant increase or significant return on the value proposition. So that's the purpose, if we think about it. The purpose isn't so much that the company's got to go out, it's got to break even, it's got to do this, it's got to do that. Ultimately, the startup company owns an asset or owns assets in the form of intellectual property, and you put capital in to increase the value of that asset. Just like if you owned a stock and you look online, you say, well, my stock went up in this much value. That's what we're trying to do. It's all about value proposition. So, now I'm talking to you folks right here. Sorry about that. People, let me get this back on so I think they're recording it. People with know-how, smart people, people that know how to do things and understand how things work, are really needed to create value. You need people like the folks in this room. The world needs more and more people like you. And in any company, you're going to find there's all these different jobs and so forth. But in a technology company, the people that actually know how things work and know how to do things are like gold. So I just point that out. You know, your technical expertise, you develop product development expertise, all these different things here. But somebody has to make it work. And I've been making products and putting products out since the 1970s until now. And you build all this infrastructure around here, but the core of people who actually make the gadget work or make the test work or whatnot is usually reasonably small. It's not usually hundreds of people. It's usually 10 people or 15 people that are actually the core that figure it out. And so what I'm suggesting is, if you're one of those people, then you've got a tremendous career opportunity ahead of you. You just have to find the right place and the right match for that if you enjoy making things. Because somebody really has to sweat the details. If we look at a startup company as far as its evolution, and there's a lot in this particular graph, but I wanted to cover just briefly the idea that over time, you raise capital different ways. You can talk about angel investors, which are people that just decide to put their own money in, as opposed to venture capitals, is to get other people to give them money, usually big institutions like retirement funds and so forth. See how that's worked out in Illinois. But you and venture capitalists then invest other people's money, and so that's kind of the difference. I don't know which one's smarter, investing your own or getting other people to give you money to invest. And then they charge people. They not only invest other people's money, but they charge them for the privilege of investing their money for them. It's kind of an interesting concept. But anyway, you have venture capital money that's invested here. But what I wanted to get was you kind of have the founding time here. You have an early stage company, a later stage company, and then initial public offering, IPO here. The company might be put on the market where you have public stock offered, or it might be sold to another company through a merger and acquisition situation. And so you kind of have this growth. And the orange line was kind of like maybe profitability, and the stepped line there is maybe kind of like valuation and funding related to the company. But you see that this valuation will increase over time as you've added value to the product and the intellectual property. And so I mainly want to talk about these phases, though, the early the founding phase, the early stage, and later stage, because too many times when people think of a startup company, they only think of the founding stage. And that's not maybe the best way to thinking about it. So I'm gonna get back to that in just a minute, but I want to just mention, I personally find working in a startup company, and when I say startup, I don't mean just this stage here where it's just getting founded, but the startup as you move towards the sale of the company, I personally find it to be an enormously rewarding place to work. There's close relationships. You're working on really challenging, fun stuff. You're inventing things. You have a lot of impact on what's going on. You have the opportunity to innovate, and you get to broaden your experience. In a startup, you're going to have the opportunity, like I was in a small division of Coulter Corporation. It was a multi-billion-dollar company, but Wallace was really interested in our division. I was the third employee in there. It was like being in a startup. So I got to know him. And so in a startup, you're going to get to know the CEO and the head of marketing and all the key executives in the company, and you're going to get to learn a lot about the overall operation of a business. So I like that. It allows you to help develop leadership and communication skills, and really gives you a lot of very positive feedback and the opportunity to achieve. Now, and I'm not going to spend much time on this, but those of you that are developing medical devices are probably familiar with the stage gate development process, and usually have 5 phases of development. And they talked a little bit in Jed's thing, and this really kind of follows along with those ideas. But the main point I want to put it up here is that you will gain, no matter what you want to do in your career, I mean, even in the academic world, but you will gain so much experience from moving through a formal development process of any product, learning all the different phases, learning what it takes to move from the beginning to the end, whether you're going to end up working in a large company, small company, back in academics or so forth. The value of learning what it takes to move through those stages can be really exciting. And technically competent people are needed at each stage. So, you know, you're first looking just at ideas, then you create proof of concept products, and you have to work out the business case. Well, you need technical people at each one of these stages to evaluate intellectual property, to participate, not just to invent the thing, but there's opportunities in every aspect of the business. Some positions that could be available to a startup company. Certainly basic research. Startup companies are writing grants all the time, SBIRs, STTRs, working with the federal government depending on their product, or maybe the Defense Department depending on their product. Course product development and design, V&V, verification, validation, both performing and leading. Market research, intellectual property management, quality and regulatory assurance, in-house customer support, product sales and marketing. And one of my favorite jobs in a relatively small company is the field technical support job, where you go out and work with the users of the device. You get to travel around, visit their labs, sit down with them, solve problems in their labs. It's a really rewarding job. It's a fun job. You get to just go solve problems with people, and are always happy when you leave and it's all working and they're happy and it's figured out. It's a great positive feedback job. So, you know, I really like that, because you need scientists, you need people who understand how things work to go out and interact directly with the customers, especially in an early stage company, because they're figuring out new stuff all the time. And so that's just, I got to do a lot of that early in my career, and I just had a ball. I think if I picked one job I've enjoyed doing more than any other job my whole career, it was that. Just traveling around and making people happy everywhere I went. So, okay, well anyway. So, now this is the point I wanted to make about the startup. When do you want to join a startup? And that's why I want to make the point that I consider this entire path to be the definition of a startup company, before it's sold and before it goes public. You know, this whole valley of death time here, I'm not so sure about that. It's not a bad place, and that's where the real founding of the company is. And so if you join at that time, it's called the valley of death because a lot of them die there. And it's a lot of work. Nobody ever has any money. There's, you know, how are we going to make this? We're just figuring things out. It's not a bad time, especially if you help to invent the technology and it's kind of your baby. Then you can kind of deal with that. But if it's not your baby, it's a tough time to join a startup because it's a lot of work. However, this period out here, what I call the early stage growth period, so after they've kind of gotten what they'd call their Series A funding round, they've got a few $1 million of funding lined up, but they have to get the product going, that's a good time because there's excitement, there's a plan, things are moving, and financially, especially if you're getting some of your compensation in the form of stock options, it's a good time to join because your stock options, the value change in the company is going to be significant during that time. So that's still a good time. You don't have to join here to see the real appreciation of value, because really a lot of the appreciation of value of the company comes here. So from a career point of view and a compensation point of view, it's not a bad time to join a company in the early stage, or even in this part of the later stage, because this typically will take 3 to 5 years for this to happen in here. So I encourage you to think about being part of a startup company doesn't mean you have to be part of it at its very origin. But you can look for startup companies to join in this time, and it could be a great career move. So if I was going to give you some practical advice about how to find companies that are in that, because how in the world do you find? There's a million of them out there. There's a million of them out there. How do you find companies in that right phase? Well, my first advice would be to do your own research on this and follow the money. You will have specific skills, things that you really understand and know how to do. And there are startup companies out there in that early stage development that desperately need your skills, and they might even know how to ask for them or how to look for them. So what you got to do is you got to go find those companies in that stage. And a great way to do that is to follow the money. You can use databases like crunchbase.com and see who's been funded. Okay, who did VC just put 5 million or 10 million into? You can really map that out. So you can go on there and search and look for companies that could utilize your resources, and target companies. And it's a great thing to do, to target companies that just got money, because they're probably going to be looking for people. And if you have specific expertise that could benefit them, that can be fantastic. What Jed said about selling the product before, your product concept and relationships, is really important if you're going to look for a job, is to learn how to sell yourself. And the best way to do that is to make connections with people. You just have to talk to them and find out what they're doing and tell them what you know. Most of the technical connections and the really important technical hires I've made, and the way I got hired, is that I had casual conversations with people where they learned who I was and what I did, and I learned what they needed. And it just worked out. So I'm very relationship based on that. But how do you do that? Well, one of the best ways to do that is to attend big meetings and spend a lot of time on the trade show floor, but you don't just go there and walk around and not talk to anybody. You have to get over that and just talk to everybody. Just talk to everybody and tell them, what you do, and it's just amazing how quickly that information will pass. And if you go to the different booths of companies who are exhibiting, just talk to them. Tell you what your expertise is. Have cards to hand out, and you'll meet people. Word will get around. So I encourage that a lot. Sell yourself, and then adding some skills. Communication is huge. Learn, if you're an excellent communicator, if not, become one. But gaining some skills in regulatory, and how do you become a great communicator? You just do it. Just talk to people. Talk whenever you can. I don't have any problem with that. I've been talking my whole life. This problem, I guess. Anyway, but adding regulatory and project management. If you take expert scientists and add, if I'm looking at a resume, expert scientists, and they know something about project management, they know something about the regulatory environment that I'm working in, they're on the top of the pile. If you can just explain that 5-phase stage gate development program, you're on the top of the pile. That's so. I just point that out. Those are great skills, and they don't cost much. You can go to a 6-week seminar on FDA product development and come out with a little certificate, and it's gold to add to your scientific expertise if you're out looking for a position. Okay, so then what if the startup fails? Because most of them do, right? So if you're working for a startup company that fails, well, relax. You can celebrate your experience. You're now a seasoned startup professional, which now goes on top of the pile if you're looking for a job. And then you're looking for a long-term position. If you've got experience as a startup, you can get contract work. It's easy to do. There are hundreds of thousands of tech startups looking for staff, and if you're experienced, that's even better. So I'm not talking about necessarily being a founder here, but if you're a part of the scientific staff of a technical staff at a startup and you've got experience, going out again and finding another one is not going to be that tough. So I'm kind of putting this out here because from a career path point of view, we get a lot of view of what can be done in the academic world. We get a lot of view of what can be done working for big companies, Siemens, GE Healthcare, so forth. But there's not a lot of emphasis on how do you go about finding jobs in that startup environment, which I think is a great place to work. It's fun, it's exciting, you get to invent things, get your name on some patents. It's just a good time. So I can't say enough positive about it. So I wrote a few questions here. I don't have to answer these questions. I've used kind of the time that was allocated to me, but I'm happy to either answer any questions if somebody wants to pose them, or if you've got a couple of questions, answer yours as well. It's a pleasure getting to meet you all.
Thank you so much, Gary. Any questions?
So in terms of what you do if you're starting sales, how do you kind of, are there any key words or phrases you've used or know people have used, or any way to like spin it in a good way if you go out looking for a job or trying a new startup?
Well, if you're, it's not bad. I mean, spin it in a good way is that you've got experience. I mean, if you go out and look for a management team, right? If you want to get funded by VCs, for example, you'd rather have a management team that's maybe failed a couple of times before because they know what not to do. When it comes to the scientific world, though, you just spin what you've done. Spin the positive things. You can start to fail all the time for things that have nothing to do with the individual scientific staff. So my point is, I don't think there's stigma. There just isn't stigma for being associated with something that was challenging to do. It didn't work out, that's fine. Move on. So, yeah, just focus on what you did. Yeah.
Two questions. So the first one is that you showed this value of death.
Yeah.
And do you think like joining a startup at that stage is proportionally rewarding if it succeeds? You know, like
it'd be rewarding if it succeeds.
So is it proportional to the risk that you take it in?
Depends on a lot, your life situation and everything else. If you've got debt mounting and kids to feed and things like that, then maybe that risk is overwhelming. If it really doesn't matter that much one way or the other, and you're living in your car, well, who knows? So it has a lot to do with that. It's high risk. That early stage stuff is very high risk. So.
The second question, actually, I heard something. I want you to say how much wisdom is in that. So I see you mentioned that as your background was like mechanical engineering.
No, I'm an electrical engineer.
Yeah. So
I just designed a fan. I was working as a mechanical technician while I was in engineering school.
So I'm not often, but I hear from people that if you are an electrical engineer and get involved in something that is very close to what basically, let's say your field of expertise or your baby, then you'll be less flexible basically in terms of changing the plans or to adapt to the realities in the industry or so do you think it's a good idea, like once you're done with your degree, just to start to get involved in a startup that has less to do with what we did, or what did?
Well, the emotional attachment is tough because if you're emotionally attached to the technology, the product, well, you've got to have somebody give you reality checks on that, and you probably need to have other people making some of the decisions. I say that you compensate for the emotional attachment by having an agreed upon decision-making process. So process is what you use to compensate for that. So if you have process that says the thing has to do A, B, C, D, and E, and these are the metrics, and that's what it is, we don't need the metrics, then we don't go forward. You have to set things up like that. What the counter, though, is if you're passionate about something, then the passion of believing in that this is really the thing can really be very, very positive. So it's a balance, but I agree that when you have the inventor involved, I was the inventor and I was the leadership, and the biggest mistake I ever made in my life, in my professional career, as far as business, is I had a scientific advisory group come and look at a prototype product that I thought was ready for commercialization, and they looked at it and they said that I needed to do certain things that in addition, and that was their advice. It was good advice, and I ignored it. It was a huge mistake. Because I believed, I had my faith that this was the right thing to do, and I was dead wrong. And I should have listened to what the people said, and I ignored my process. So
not only the health, but the process can compensate.
Other questions? If not, let's thank our.
Alrighty, go on.